we want to find the coefficient of power series. So how gonna find the coefficient for power series? We're gonna use derivative of f prime x. So let's take derivative both sides here, f of x and power series. First derivative f prime x gonna be a0 gonna be derivative a0 is 0. Here is x minus c, derivative is 1, that's 1 times a1. Here is a2, x minus c square derivative 2a to x minus c cube derivative is 3a3x minus c square, so on. Let's take a second derivative of f of x. So that's gonna be a1. First term gonna be 0. Let's do second term. X minus c, derivative x minus c gonna be 1. 2 times 1a2. Derivative x minus c square gonna be 2a3x minus c. Power is 1. This term gonna be 3x minus c square. So let's take one more time. Third derivative gonna be, this term is gone. Second term, derivative x minus c gonna be 1. 3 times 2 times 1. This term, derivative of this one is x minus c squared. That's gonna be 4 times 3 times 2, a4x minus c. So now we want to find a0 here, guys. So you plug in the center, or power of x term gonna be 0. So you have f of c equal a0. So you find a0. a0 gonna be f of c. Now, we find f of 0. Now we need to find a1. Same thing. You're gonna plug in the first derivative, x equals c. Center, this term gonna be 0, guys. So f prime c, then we have 1 times a1. I'm gonna put the 1 factorial. So a1 gonna be f prime c over 1 factorial. Now, let's go to a2. Same thing. We're gonna plug in the x equals c. That's gonna be second derivative c. 2 times 1 is 2 factorial times a2. a2 gonna be second derivative of c over 2 factorial. I think you can guess. Next one is we're gonna find the a3. You plug in the x equals c. F third derivative of c equals 3 factorial times a3. That meaning is a3 gonna be f third derivative of c over 3 factorial. What is an gonna be, guys? Now, f third derivative is this form. F fourth derivative gonna be take one more derivative. Looks like that form. So we find f fourth derivative of c gonna be 4 factorial a4. So a4 gonna be f fourth derivative of c over 4 factorial. Can you see this one? a4's coefficient, degree 4, coefficient gonna be fourth derivative f of c over 4 factorial. So a0 gonna be fc, a1 gonna be f prime of c over 1 factorial, f2 gonna be second derivative of c 2 factorial, f3 gonna be third derivative of c over 3 factorial, f4 gonna be fourth derivative of c over 4 factorial, an gonna be nth derivative of c over m factorial. Now we find the coefficient for the power series. Now let's write the power series for given function. Fx gonna be a0 plus a1x minus c all the way an x minus cn plus go on. We find the coefficient for each term. So a0 gonna be f of c. So f of c first coefficient. A1 gonna be f prime of c over 1 factorial. A1 gonna be f prime of c over 1 factorial x minus c. A2 gonna be second derivative of c over 2 factorial. So second derivative of c over 2 factorial x minus c squared. A3 gonna be f third derivative of c over 3 factorial. So coefficient for degree 3 term gonna be f third derivative c over 3 factorial x minus c cubed. A4 gonna be fourth derivative of c over 4 factorial x minus c fourth power. An gonna be fn's derivative of c over n factorial. So that's gonna be fn's derivative of c over n factorial x minus c n plus. Now we found power series for given function. What do you call this power series? We're gonna say Taylor series as center gonna be C. Now let's give the definition of Taylor series. Fx is a function. We want to write fx as the power series. Center is at C. So that's gonna be right here. Here is f of x. This is a power series. We find the coefficient an. An gonna be fn's derivative of c over n factorial. So we can replace an by fn's derivative of c n factorial. Now, that's we have. So fx gonna be power series and fn's derivative of c over n factorial x minus c to the n. We call this one is the power series of function of f centered as c. So when you give the function of f of x, you're going to find the derivative of f of n, put the center value, x going to be c, then we're going to find all coefficient of each power. We call this a Taylor series. When center is 0, then we call Maclaurin series. Center is 0, fn's derivative of c over n factorial xn. We call this series is Maclaurin series. Center gonna be 0. So expand the series looks like f of 0, first derivative of 0 over 1 factorial, second derivative 0 over 2 factorial, so on. Let's look at the geometric power series we studied in previous session. Compare power series to Maclaurin series we studied here. So here is rational function power series, geometric power series right here. Now, fx gonna be 1 over 1 minus x. Taylor series say, this is the center is 0. We call Maclaurin series gonna be fn's derivative of 0 over n factorial times xn. How this fn's derivative of 0 over n factorial gonna be? That's we're gonna compare geometric power series, Maclaurin series for f of x. So power series right here, summation n equals 0 to infinity xn. Maclaurin series for rational function gonna be this form. This should be same because it's same function. Left side, I'm gonna expand the sigma notation 1 plus x squared x cubed. Right side, expand the sigma notation gonna be f of 0, f prime of 0 over 1 factorial x, f second derivative of 0 2 factorial x squared, so on. Left side, right side should be same, which meaning is 1 should be same to f of 0. That's constant term. So f of 0 gonna be 1. X gonna be same f prime of 0 over 1 factorial x, which meaning is coefficient here is 1. Coefficient right side f prime of 0 over 1 factorial. So what is f prime of 0 gonna be? 1, right? X squared is left side is same as second derivative of 0 over 2 factorial x squared. Coefficient x squared gonna be 1. Here is right side, the coefficient of x squared gonna be second derivative of 0 over 2 factorial. So f second derivative 0 over 2 factorial gonna be 1, which meaning is f second derivative of 0 is 2 factorial. Let's compare degree 3. Degree 3 left side, coefficient is 1. Degree 3 right side, third derivative of 0 over 3 factorial. So, third derivative of 0 over 3 factorial equal 1, which meaning is third derivative 0 over 3 factorial. I think you can guess what is next one. So xn, degree n term, exactly same is right side degree n term. So fn's derivative of 0 over n factorial equal 1 gonna be fn's derivative of 0 gonna be n factorial. Now, we find fn's derivative of 0 without taking derivative of f of x because we know the power series of this function. So fn's derivative 0 gonna be n factorial. Let's find the Maclaurin series for exponential function. How gonna find Maclaurin series for exponential function? E to the x gonna be summation fn's derivative, plug in the center is 0 over n factorial xn. So we have find fn's derivative of 0 over n factorial, which meaning is we have find fn's derivative 0. So let's take derivative function of f of x first, okay? So f of x gonna be e to the x. When you plug in the center 0, f0 gonna be 1. E to the 0 is 1. Take a first derivative. F prime x gonna be e to the x. So f first derivative of 0 is also 1. You take one more time. Second derivative of f of x gonna be e to the x. Second derivative 0 is 1. So third derivative of f of x gonna be e to the x. Third derivative g gonna be 1. Fn's derivative of x still e to the x. Fn's derivative of 0 is 1. So e to the x. Maclaurin series e to the x gonna be f0 plus f prime 0 over 1 factorial x, second derivative 0 over 2 factorial, and so on. So f0 is 1, f prime of 0 is 1, second derivative of 0 is 1, third derivative 0 is 1, fourth derivative 0 is 1, nth derivative 0 is 1. So you find the Maclaurin series for e to the x. So that's gonna be 1 plus x plus 1 over 2 factorial x squared plus 1 over 3 factorial x cubed. General term gonna be 1 over n factorial xn. So e to the x gonna be summation n equals 0 to infinity 1 over n factorial xn. This is Maclaurin series for exponential function. Now, let's find the Maclaurin series for sin x. So, Maclaurin series gonna be center is 0. So you're gonna see sin x gonna be summation fn's derivative of 0 and factorial xn. That's gonna be Maclaurin series. So what do you have to do, guys? We have to find fn's derivative of 0 over n factorial. That's we have find it. So let's take derivative sign to find the first derivative, second, third, fourth derivative. So fx equals sin x. That's gonna be you plug in the 0, sin 0 is 0. First derivative is cosine. When you plug in the 0, cosine 0 gonna be 1. Second derivative gonna be derivative cosine is negative sin x. Second derivative 0 is 0 again. Third derivative gonna be derivative sine is cosine, outside negative. Then you plug in the 0, so derivative 0 gonna be negative 1. Now fourth derivative, what happened, guys? Take derivative cosine is negative sine. Go back to the sin x. So they repeated the same function, sin x, cosine x, negative sin x, negative cosine x, go back to sin x. So first derivative of 0 gonna be 0. Let's write the Maclaurin series for sin. Sin x gonna be f of 0, first derivative, 0 over 1 factorial, second derivative, 0 over 2 factorial, and keep going. So plug in the value. F of 0 is 0, f prime 0 is 1, second derivative of 0 is 0, third derivative of 0 is negative 1, fourth derivative 0 is 0. What do you have here? Here is gonna be, guys, look at this one. First degree 1, degree 3, degree 5th is survive. Even power gonna be 0. So you have x minus 1 over 3 factorial x cubed plus 1 over 5 factorial x 5th power minus 1 over 7 factorial x 7th. Let's find summation for the sin x. I want to find the general term of a Maclaurin series. Sin x, we have to write the summation n equals 0 to infinity. So start point n equals 0, sin is positive. Here is gonna be, number gonna be 1, power of x gonna be 1. Second term is right here. 1, n equal 1, sine is negative, number gonna be 1 over 1 factorial, power gonna be 3. N equal 2, sine is positive, coefficient number gonna be 1 over 5 factorial, power of x gonna be 5. N equals 3, sine is negative, coefficient number part 1 over 7 factorial, power is 7. How can find the sine term? That's gonna be negative 1 to nth power. Look at the denominator, 3 factorial, 5 factorial, 7 factorial. That's the odd number, that's why 2n plus 1 factorial. this odd number exactly power of x. So x 2n plus 1. That's the general term for the Maclaurin series of sine x. Now, let's find the Maclaurin series for cosine x. We can use definition of Maclaurin series. Also, we're gonna use calculus to find the Maclaurin series for cosine x, because we already found Maclaurin series for sine x. How can get the cosine? Differentiate sine gonna be cosine. Another way say derivative sine gonna be cosine. That's I'm gonna use here. So sine x gonna be summation negative 1 to n over n plus 1 factorial x to n plus 1. So we gonna differentiate sine. Another way find the derivative of sine gonna be cosine x. So we're gonna take a derivative both sides and find the Maclaurin series. Derivative of sine gonna be cosine. So we take a derivative this Maclaurin series. So how gonna find the derivative Maclaurin series? We gonna take derivative term by term right here, guys. This term is constant. We only take a derivative x to n plus 1. What is derivative x to n plus 1? That's gonna be 2n plus 1 x to n. Let's just simplify here. 2n plus 1 factorial meaning is, guys, 2n plus 1 times 2n factorial. So, that case, we can cancel out here 2n plus 1, 2n plus 1. Now, you have negative 1n over 2n factorial x to n. That's the Maclaurin series for cosine x. So, cosine x gonna be negative 1n over 2n factorial x to n. Let's find the Maclaurin series for cosine square root x. So we don't have to use definition of cosine Maclaurin series, guys. Maclaurin series, you have to take derivative first, second, third, and derivative. It's take a while and also a lot of effort. So I wanna use Maclaurin series for cosine because we already find it. So this case, here is only different is our function is cosine square root x. Maclaurin series for cosine x gonna be here is x, here is x. So we're gonna replace x by square root x. That's we're gonna do it. So we have cosine square root x. X will be replaced by square root x right here. That's gonna be this form. Negative 1n to n factorial square root x to n. Let's simplify this term, guys, okay? Square root x gonna be, power gonna be what? That's the 1.5, 2n, 1.5, 2n. You have times it because that's exponent. 1.5 times 2n is n. Now you have Maclaurin series cosine n. That's going to be negative 1n over 2n factorial xn. So what are you going to say? If you have some Maclaurin series, you can use Maclaurin series, we now find a similar function, okay? Let's keep in mind. Let's have another example. So we want to find the Maclaurin series f of x arctangent x cubed. We already know arctangent, Maclaurin series for arctangent. That's the Maclaurin series for arctangent. Only different is x cubed. So here is x, here is x. You're going to replace x by x cubed. That's all you have to do. So arctangent x cubed gonna be replaced. X cubed will be plug in the x in the Maclaurin series. So here gonna be x cubed. So we have to simplify this one. So let's simplify. Here is x cubed, 2n plus 1, that's power. 3 times 2n plus 1, that's we have to it. That's 6n plus 3. So now we find the Maclaurin series arctangent x cubed. That's gonna be summation negative 1n over 2n plus 1 x 6n plus 3. Let's find the Maclaurin series for x squared e to the 2x. How gonna find it, guys, right? So first, before we start Maclaurin series for x squared e to the 2x, let's find the Maclaurin series e to the 2x first. But we know only e to the x gonna be x nth power over n factorial. Can you find the Maclaurin series e to the 2x? Yes. So x, here is x. We're gonna replace x by e 2x, right? So e to the 2x gonna be, here is replaced here, e to the 2x, right? That's, we're gonna figure it out. So let's see, simplify this one first, guys. Just simplify this one first. So what is gonna be? That's gonna be e to the 2x gonna be 2x n. You're gonna distribute the power e to the n, x to the n. Now, we need to find the Maclaurin series x squared e to the 2x, right? So that's we're gonna do it. What do you have to do? E to the 2x is e to the n, x n over n factorial. We times x squared both sides. X squared e to the x gonna be f of x. X squared Maclaurin series. So put it x squared inside the sigma. Then you have e to the n over n factorial x squared times xn. 2 plus n is n plus 2. You find the Maclaurin series f of x, 2 to the n over n factorial xn plus 2. Let's find fn's 100 derivative of 0 for fx equal x squared e to the x. Previous slide, we find the Maclaurin series of x squared e to the 2x. That's gonna be 2 to the n over n factorial xn plus 2. When you expand this Maclaurin series, n equals 0, n equals 1, n equals 2, you keep expanded, we have this Maclaurin series. Now, it's impossible to find f100 derivative of 0. So we're gonna use definition of Maclaurin series. So we find the Maclaurin series for fx equal x squared e to the x. This term is an. So an gonna be 2n minus 2 over n minus 2 factorial. An is coefficient for xn, guys, okay? That's the 2n minus 2 over n minus 2 factorial. But Maclaurin series, definition of Maclaurin series say fx gonna be right this way. Fn's derivative of 0 over n factorial xn. This definition of Maclaurin series, an gonna be fn's derivative of 0 over n factorial. So this should be same, guys. Fn's derivative 0 over n factorial. So which meaning is fn's derivative 0 over n factorial equal to n minus 2 over n minus 2 factorial. So fn's derivative 0 gonna be 2n minus 2 over n minus 2 factorial times n factorial. So this one is 2n minus 2 times n factorial over n minus 2 factorial. We are looking for a f100 derivative of 0. That's what we are looking for. So you plug in the 100 here, and n is 100. 100 minus 2 is 98. So 2 to the 98 times 100 factorial, 98 factorial. 100 factorial meaning is 100 times 99 times 98 factorial. 98 factorial cancel out. 98 times 100. 9900 times 2 times 98. So we find F100 derivative of 0 right here by using Maclaurin series. Let's have one more example for that. Now this time is we are looking for here is F105th derivative of 0 for fx ln 1 minus x. So don't try to find F150 derivative. So we can use Maclaurin series for fx is ln 1 minus x. If fx ln 1 minus x Maclaurin series gonna be negative 1 n plus 1 x n plus 1 power, we're gonna expand this Maclaurin series, then looking for the coefficient of x n's power. Right here, guys, you find it, an gonna be negative 1 over n, right? So Maclaurin series definition say coefficient of xn gonna be fn's power of 0 over n factorial. That's we're gonna have put this equal because an from Maclaurin series we find an from definition of Maclaurin series should be same. So from here, fn's derivative 0 is over n factorial equal negative 1 over n. So fn's derivative 0 gonna be negative 1 over n times n factorial, which meaning is negative n factorial over n. So now we are looking for the 150 derivative. You plug in the 150. So F150 derivative gonna be negative 150 factorial of 150. So 150 factorial meaning is 150 times 149 factorial over 150. 150 is cancelled out. Answer gonna be negative 149 factorial. That's you're gonna find F150 derivative of 0. This one is, now we're gonna find the function represented by power series. So I give the power series, Maclaurin series right there. Then this power series represent which function? How do you figure it out? So I give the table of Maclaurin series right there. You guys really focus on the coefficient. So coefficient does not change, guys, here. So here is n factorial is bottom. Look at the table of Maclaurin series. Which one has n factorial? N factorial is only this one. Maclaurin series for e to the x. So we're gonna using this Maclaurin series to figure it out for the function of Maclaurin series, this power series. So this one is n factorial, n factorial. So e to the x is gonna be xn over n factorial. Numerator, write xn. So that's we have figured it out. Here is the power is n. You're gonna put together that one, guys, okay? So you're gonna put together negative 1, 2x outside n. So inside gonna be negative 1 times 2 times x. That's gonna be negative 2xn. Now, look at the Maclaurin series for exponential function. Parenthesis is gonna be here negative 2x. Here is x, exponential e to the x. Now, parenthesis negative 2x, meaning is this Maclaurin series represent e to the negative 2x. So now we find the function represented by this power series. So this power series represent e to the negative 2x. Let's have one more example to find the function represented by Maclaurin series. So I give the Maclaurin series right there, guys. Look at this series. Then we have a table for the Maclaurin series. So previous example, you have to look at the denominator. Denominator cannot be changed. So find denominator n plus 1. That's gonna be right here. That's the Maclaurin series for ln 1 plus x. So ln 1 plus x gonna be negative 1 and n plus 1 x n minus 1. So really focus on here, negative 1 and n x n minus 1. You have to really see it. So that you need to find from this Maclaurin series. But look at the top, 3n plus 2 times xn plus 1. xn plus 1 here. But power of 3 going to be n plus 2. Then you split 3n plus 2 equals 3 times 3n plus 1. Then you see power gonna be n plus 1 right here. 3 is you don't put the inside sigma, so you take it out in front of sigma. Now exactly what are you looking for? Power gonna be n plus 1, n plus 1. You see put together, that's the 3xn plus 1. This one, this power series, Maclaurin series, is exactly Maclaurin series for ln 1 plus something. So look at this one more time. 3x, that's gonna replace by x. So we see 3 plus ln 1 plus 1 here. That's gonna be 3x. So now we find the function represented by this Maclaurin series. That's gonna be 3 times ln 1 plus 3x. Let's do another example to find the function when I give the power series or Maclaurin series, same thing. So here is focus on denominator, that's the 2n factorial. Where can I find 2n factorial is denominator? We see on the table for Maclaurin series cosine x right there. 2n factorial, 2n factorial. So this Maclaurin series represent cosine function. So what is gonna be input? That's we're gonna figure it out. So negative 1 and n, 2n factorial, negative n, 2n factorial. You're looking for x to n. Here is x for n. So x for n should be changed form of x to n. So how gonna do that? X for n is x squared power to 2n. 2n times 2 is 4n. So you rewrite the power series, negative 1 and n x squared to n. So this is represent cosine. What is gonna be input? So it's here. What is input? X squared. So you're gonna plug in x squared to the cosine x. Now you find the function for this Maclaurin series. That's gonna be cosine x squared. Let's have another example by using Maclaurin series. This question is a little different from previous example. We want to find the sum of series, not the function, guys. So we want to find the sum of this series. There's no variable, which meaning is this is not the represent function. So how gonna find the sum of this series? So we're gonna use table of Maclaurin series right there. So the tool to find the sum of this series is the same way we did in previous slides. So first we have find the function which is related to this series. So check the denominator, that's the 2n plus 1 factorial. Find the function which has power series, Maclaurin series with denominator 2n plus 1 factorial. That's going to be right here. So you have a clue, this power series, this Maclaurin series related to sine function. So sine x, negative 1 and n, 2n plus 1 factorial x 2n plus 1. Now, second part is numerator is negative 1 and n, negative 1 and n. 3 2n plus 1. X is 2n plus 1, but here is 2n. So you have to do something algebraically. So you need 2n plus 1, that power. So I'm going to do, right here, guys, what I'm going to do is 3 to n, you need 2n plus 1, which meaning is you need 1 more 3. You times 3, you divide by 3, meaning it's 1/3. So that make 3 times 3 to n is 2n plus 1. So this power series, series is gonna be 1/3, 3 times 3 to n. So this term make 3 to n plus 1. 1/3 is outside this sigma. Now 3 times 3 to n is 3 to n plus 1. That's exactly same as power of Maclaurin series in the sine function. So here's the power is 2n plus 1. Here's power 2n plus 1. So this one is a form of Maclaurin series for sine. But what is going to be input here? That you have figured it out. So this is going to be 3. X will be replaced by 3. So this series right there, 1/3 sine something is gonna be 3. So we find the sum of this series that's gonna be 1/3 sine 3. Let's summarize what you learned from this lecture, guys. The first one is, what is Taylor series? It's Taylor series represents the function as infinite sum of power of x minus c. C gonna be center. What is coefficient? Fn's power of 0 divided by n factorial. Maclaurin series gonna be power series. Power series, center gonna be 0, right? Then this series will allow us to express, approximate, analyze complex function like sine, cosine, exponential function by using simple part of x.